So now that we've seen how polynomial functions can be derived, and once again, just to look at the general example, if you have f of x equals ax to the n, then f prime of x is equal to a times n times x to the n minus 1. You multiply the n, and you bring away 1, and that is your derivative. However, now we're going to go through and take a look at some trigonometric functions and see what their derivatives. So let's look at the one of the most basic ones, sine and cosine. So if we plot out sine and cosine, remember cosine is an even function that starts at the top. They both have a period of 2 pi, so it starts like this and continues on, and the same in the other direction. Sorry, I know my amplitude is really messed up, but it should be same above and below. But for the purposes of derivatives, I think we'll be fine. So, now remember when we were sketching derivatives, what did we first look for? We look for places where the function is flat, such as this right here, right here, right here, and of course it keeps repeating, so on, and of course in the other directions. So at those points, the derivative, which I'm going to put in red, crosses 0. So it crosses 0 there, 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 and so on and so on. So if it crosses 0 there, next we go through and let's look at all the places where the function is increasing. So there, here, here, and of course, so on and so on. So during all of that part where the function is highlighted in green, the derivative is going to be positive. It's at its steepest right in the middle of each of those, so that's where the derivative is going to have to be highest. So the derivative at that point will have to look something like that. Like that. Like that. Oh, sorry. And so on. Now let's go through and see where it's decreasing. Right there, right there, there, and there. Once again, the middle being the steepest point of, and since it's the steepest point down, it's the furthest point negative on the derivative. So we're doing that, and that, and that, and that. And it kind of makes sense that a periodic function would have a periodic derivative. For every point where it changes direction, where the function changes direction, the derivative has to go through 0. And I'm going to draw this one more time, make it look a little bit better so you can maybe see exactly what's going on. Oh, shoot. So here's our axes. And I will do, here's cosine. I'll just do 1 period on each side. And the derivative looks like, oh, shoot. So really quick, just to reiterate, so it crosses 0 here, crosses 0 here, it's negative below here, so the furthest negative point is down here, it's crosses 0 again right here, and then its furthest positive point is right here. So, see, it does something like that. Same on the other side, crosses 0, furthest positive, furthest negative. And of course, what is that green function? Well, if you remember sine, which I'll draw in blue, the function sine looks like this. So what is the green? Well, the green is just the opposite of the blue, and the blue is sine. Sorry. The blue is sine. So therefore, the green, that's the 3 dots is a symbol for therefore, the green is equal to negative sine. Sine is equal to green. And so, as you can see, since red is cosine, that the derivative of cosine is sine. So, dx of cosine is equal to negative sine. I might have said sine earlier, but it's negative sine of x. So there should be x's in all those. Now, let's imagine that our original function, So our blue, instead of red being our original function, let's imagine that sine was the original function. Well, what would the derivative look like? So if this was our original function, this blue line, I'll retrace it in black, then what would our derivatives look like? Well, the derivative will cross 0 here, cross 0 there, cross 0 there, and cross 0 there. Well, if you look down, the sine function, or excuse me, the cosine function does exactly that. Ooh, that one's off a little bit, but I'll just draw it like that. There, now it does. So the other thing to look at is the directions of the cosine function, or the sine function, sorry. So once again, the parts where it's increasing is right here, which means that the cosine function would have to be positive. Well, if you look at the cosine function, which is that red, it is positive all along where the sine function is green. The cosine function is positive. And where the sine function is negative along these parts, the cosine function is already, or where the sine function was decreasing, that was those blue parts, where the sine function was decreasing, the cosine function is already negative. So it crosses 0 at the correct spots, and it has the correct signs. So intuitively, it looks like the derivative of sine, so d dx of sine is equal to cosine. So we figured out those are the two most important and the two most basic trig identities. In the next video, maybe we will go over some of the more complicated ones or look at some more examples, but that's your basic geometric proof for those. So see you guys next time.